The biggest mistake that most engineering students make, especially in electronics, electrical, ICE, and related fields, is it's not their mark, it's not their college that they choose. It's one simple thing. They don't have a proper roadmap. There is no proper roadmap, no clear plan, and no right resources, and just going with the flow. Most of the students who take up these departments are not taking it voluntarily. Either they don't get the right college, but they wanted to get into these core branches, or they don't have enough marks to get into any of these IITs or those, and they end up in these particular branches. I think out of 100 students studying in these branches, 90% of them had no choice and just to take this branch, and only 10% of them had chosen these branches on their own. If you agree with me, let me know in the comments. If you are into BTech or whichever college you are studying, please let me know in the comments as well. So if you're watching me for the first time, I am Sarvesh and I create content about hackathons, internships, placements, and related to circuit branches, more into core and stuff like that. So if you're watching me for the first time, subscribe to my channel. We are close to 5,000 followers. The goal is to get to 10,000 subscribers by end of December, and that is maybe a small goal. And if this video is helping you and your friends, please share it with them and ask them to subscribe as well. So yeah, let's get started. So if you are in ECE or similar branches, and if you want to actually crack into core industry, for example, VLSI, embedded systems, robotics, and communication, then this video is for you. So these are the different powerful career paths in core engineering: VLSI, embedded system, robotics and automation, and communication. This video is basically, I'm going to give you a proper roadmap. Okay, this is just level 1 roadmap, and this is going to be a complete roadmap for EC. Like, you'll have a concept understanding of what you need to learn in your college. See, out of 54 subjects that you have, you need to study these things more, give more importance to these subjects for your core placements. I'll also give you where I have studied it from. You need not buy books or something, whatever is available in your library. I'll just give you examples of that and what YouTube channels that you can refer to. The main thing about core is you need to be specializing in one of these domains. Like, while you're studying, you need to specialize in one of them, but also you need to have an understanding of all the core concepts when it comes to your placements. So you need to have a wider understanding of all the branches and a deeper understanding of any one domain that you want to pick. So in this video, we are going to cover that wider understanding, that roadmap, and the upcoming videos I'll be talking deep dive into VLSI roadmap, embedded systems, robotics and automation, and a lot more. If you have any requirements of what I should make videos on the next videos, please let me know in the comments. I'll be coming up with the one very soon. Yeah, so these are the powerful career paths that we have discussed earlier. So this channel is for ECE core, core branches. I'll also bring my friends who are into other departments as well, like mechanical, civil, if you want, biotech. All these people who have my friends have got placed in good companies. I can bring them, give very good roadmaps for you. So the biggest mistake is there's no proper path that you guys can follow, right? What we do, like initially what we do is, like, we just get started in the first year. We just roam around with friends and like go to labs, study this physics, boring chemistry and stuffs like that. And then second year we'll decide, this brother told me that he's preparing for gate exam, should I also prepare? Like, will it be good for me? Something like that, that will be your second year, something like that you'll be thinking. And third year will be like, oh my god, the placement is near, let me start preparing for software. I'll start with Python, I'll learn DSA and maybe switch into IT industry. This is what you get into third year. By fourth year you'll just be like, I just need any job, ab to kuch job chahiye jo bhi ho. So something like that you'll have, right? Like edo or job catch up or something like that you'll have in your mind. But this is what happens in most of the core industry, core engineering students, and the reality is that a lot of people are not getting placed. So as I mentioned, you need to have, I'll be giving you the fundamental roadmap. So this video is applicable for anyone who is watching. If you're from first year, second year, third year, or even your final year, you can get an understanding of how the flow is and where you are at right point, if you are in the right direction, and at what level you are, so that you can make some corrections and get into it on the process, like as you go ahead. So the first things first, these are the basics things, okay. You can't get into the level 4 without doing all this, right? So you need to start from basics, build the foundation, then get into each specific domain of your interest. So as said, programming is the first, first foundation that you have. So I'll be covering upon the all the other foundation things that you will be learning in core branches, that is programming. So especially what people think, like how many of you think like I'm in a core branch, I don't need to do coding. So this has been a myth that is being carried in people's mind when they are in first or second years. When they go for your placements, right? That time they realize, bro, I should have studied earlier. Like I should started programming earlier. So if you are thinking like I'm into core branch, should I need coding? Please change your mind. In 2025, a core engineer who can't code, it's like electronics lab without power supply. There's no use of it. So it looks good on paper, but it cannot do much. So the right time for you to learn in your the first year is start with C programming. Okay, there are a lot of programming languages, but C is the most basic one, and that is where you need to start. And in C, the most basic and most important language for core roles, as in like you'll have it in embedded system, device drivers, microcontrollers, low level hardware interaction, and most embedded system firmware, OS, internals all have C somewhere in their their processor. So here is what you will have to learn and see. I don't tell like you have to learn as much as computer science people do, but these are the things is a must. These are the basic stuffs that you have to learn. There is no excuse if you don't learn, okay. So you have to start with the basic syntax and variables, data types, operators, if else, loops, functions, and then you need to move to data structures like array, strings, pointers, then go to file handling, right? So DSA is not only for CSE. Understanding data structure also helps you to write efficient C code. Okay, whatever the system you are seeing, whatever my phone that I'm using, right? All these have hardwares, and on this only programming is going to run. Whatever program is developed by a CSE software engineer is going to run on this hardware. The truth is that even the hardware systems have programs written for it to function. So I'll also give you a few resources that I had used. Like for example, for learning theory. For learning theory content, I used Neso Academy. Basically, so mostly I'll be referring to Neso Academy because it is in English, and a lot of you would relate with it. And if you are someone comfortable with Hindi, I can also refer you more things. But like since I know my audience, like most of them are like I mean a mixed set of audience. I can't go specific to one particular language, but if you want, let me know in the comments. I'll give resources for that as well. You can learn C programming from Neso Academy if they are not teaching in your college. If they are teaching you in your college, prepare thoroughly. C is important. And then there is also free code camp. So it's basically a free YouTube channel. There you get like 5 to 6 hours of one full stretch video. There you can learn general and build solid basics, okay. By learning a programming language, it's not just watching videos, writing down notes. You also need to practice what you have learned. That is the most important part when it comes to learning a programming language. So what I would say is go to hacker rank and get at least keep a target of getting 4 stars or 5 stars in that particular programming language. You can go to like hacker rank website. You'll be able to find for each language there'll be a different path. They will have some where you can practice the syntax, looping logics, and stuff like that. And a good news is that with today's development of AI tools, learning language gets easier as it goes. And like, if you already know C is something like very old and the base of languages. Language basics are going to be same for all the languages. The syntax stuff like that, and some concepts will vary as you proceed to Python, C++, and later for AML or robotics becomes much easier for you. And with that, it brings me to the sponsor of this video. This video is sponsored by Smart Brain Abacus Academy. If you have your siblings or someone who is studying in school, you can enroll these kids, studying from first standard to up to 10th standard. They want to improve their mental maths. They can learn abacus. I'm giving the contact details in the chat or in the description. You can just reach them out and book your session. If you're watching from any part of the world, they provide international abacus classes as well. So you can join on online and learn. Okay, getting back to the next part, the digital electronics. Digital electronics is the next most basic one that you should start. Digital electronics is the most common backbone if you are into learning, getting into core for topics like VLSI, embedded, robotics, digital control logics that you have to write for them, communication hardware, and computer architecture. This is the most common subject across these particular areas, right? And in today's world, most electronic devices are majorly digital. Easily 70 to 80% of the logic that around you is digital circuitry. If your digital electronics basics are weak, VLSI and lot of core roles will feel like hell for you. So what you need to cover in digital, that I've mentioned over here. So you need to take a look on the number system and logic gates, my very favorite and easiest part to learn. And like, I think most of you are very comfortable with number systems and logic gates. Like, that is like this level of digital electronics. There's a lot more to go, but considering the level of this video, I'm just getting you into the key topics that you need to master. And then comes Boolean algebra and K maps. Then combinational circuits, where you'll have adders, subtractors, multiplexers, encoders, decoders. Then will be sequential circuits that contains flip-flops, counters, registers. And you need to get a basic idea of finite state machines like FSM. But this is just the level 1 of your VLSI journey. When I'm talking about the core VLSI roadmap, I'll give you where to start, what deep details you need to be studying. So that is for like this topics, and from where you can refer. Okay, considering most of you are college, like going to the college in offline mode, I don't want you to buy something from some websites and learn and things like that. So what I use, right, obviously in all the colleges, I think this Morris Mano book, that is what I have used for digital electronics. That is available in a lot of colleges. You can just go to your library and check. This is like a go-to book that most of me and my friends studied when we were studying digital electronics. It's like the Bible of digital electronics. That's what my faculties have told me. But I think most of the college libraries will have it. And if you prefer watching YouTube videos or YouTube channels, like these are two YouTube channels. This is not a sponsored video by them, but anyway, these what I have used, so I'm just mentioning it over here. So Gatewala is basically, when I was preparing for GATE exam, it was like so good. And Gatewala, guys, if you're watching, you know what to do, from next time. Gatewala has this digital electronics playlist, and Neso Academy also has the step-by-step tutorials and playlists for digital electronics. So you can just go and check them out. Just go type Gatewala digital electronics, and there's complete playlist in Hindi. If you're comfortable in Hindi, go watch it. If you're comfortable in English, go watch Neso Academy. And I personally use these two YouTube playlists. So most of the other topics as well, I've used the same YouTube channels. So I'll not be mentioning the YouTube channels again and again, because this is what I'm going to tell you. So these two has almost all the things that I wanted to learn. So I think you can start from there, right? In upcoming VLSI specific videos, you will see how this subject is directly translated in terms of Verilog, RTL, and chip design, right? So in this video is like just to give you a gist of how you can approach your degree. So that is what the basics is about. The next topic for you to master is network theory and circuit analysis basically. You would have seen like electrical circuit analysis or network theory. These are the common names that this particular subject has. So it's basically third pillar, and it's crucial if you are aiming into getting into analog VLSI role, consumer electronics, power electronics, and many communication roles. So in this topic, what you should be like comfortable with are the fundamental laws. You won't believe, okay, when I was applying for one software company in my fourth round, they asked me the fundamental laws. It was a software company, but still they would ask you these, these are most basic laws that you should have learned, and like write them down somewhere. It should be there in your mind, like quick revisions. For that you can use it. So what you'll be have to be comfortable with is the fundamental laws like Ohm's law, KCL, KVL. Then you'll have analysis of nodal analysis, mesh analysis. There are a lot of theorems like Thevenin's theorems, Norton's theorem, superposition, maximum power transfer, and you'll have to learn like basics of transient analysis and AC analysis of RLC circuits. This is where you need to start, and this is also one of the important topics for your gate exams. So you can solve a bit of this and like here and there. So like side by side as you watch the videos, you also have to practice your previous gate questions. Like you can expect very easy questions when it comes to node analysis and like mesh analysis and things. These are most common questions that are getting asked in your interviews. So I would say as soon as you watch the video, also sit down and practice those questions as well. And the next one, electronic devices and circuits. So the EDC thing, mostly called as EDC. That's what I have studied in the name of the subject. So how can I explain you what EDC is basically? If you know digital is about ones and zeros, but EDC is mostly about how diodes work, how BJTs work, how MOSFETs actually work, and how signals behave. So how those devices form amplifiers and other basic analog building blocks. Why is EDC important? For VLSI roles, so you need to understand MOSFET behaviors, threshold, leakage, etc. For analog designs, you'll have to learn op amps, amplifiers, filters, and all of these come from EDC fundamentals. So these are the fundamentals that will prepare you get a grip on the top level topics that you'll be learning from now on. So I would say you need to focus on these particular topics: PN junctions and semiconductors, like it's the foundation. Then diodes, rectifiers, clippers, clampers, BJTs, operation, characteristics, biasing, all these are the topics. And in MOSFETs, you'll have to learn enhancement, depletion, and transfer characteristics, and what are the operating regions. You'll have a lot of cases that you'll be learning. Again, as I've mentioned, I refer to Gatewala because I know Hindi, and you can also do like if you are into it. But if you're not into Hindi, just check out Neso Academy to build both conceptual and depth. Then solve textbook problems and previous year gate questions. Previous year gate questions you can find on internet and from any of the websites. You can use them to prepare. I did like that only because in most of the interviews they ask previous year gate questions. And my my humble request for you too is, if you are preparing for your core jobs, always prepare for gate exam. It's like uh, getting two things in one process, right? If you are doing this one process of preparing in gate exam, you'll also be ready for the gate exam. You'll also be ready for the core jobs, core companies that's coming, right? So if your EDC and digital are solid, VLSI and hardware roles start opening up naturally for you. Like this is the base where you get started. Then next one of the topics which I hated, microcontroller and microprocessor. There are a lot of too many controllers and processor there, but we are still stuck. It's not stuck as in these are the basic ones, and we have, as industries have moved very far, but these are still where you have to start. Like these are the basic things that you can start learning. It's called MPMC, microprocessor and microcontrollers in most of the colleges. That's how they call it. So why is it important? Okay, as I've told you already, this is like a core stretch. This is what you have to be getting strong in initial days of your ECE journey. So this will open doors for your embedded systems, low level programming, for understanding how your code actually runs on hardware. So on this, what you will have to focus on, that is also important, right? For understanding how your code runs on your hardware, so basically you will have to focus on computer architecture, arithmetic logic units, registers, control unit, CPU, and all the buses, like how it's getting connected, and instruction sets. We have code for a program, like that's how it is getting mapped. You need not memorize all that, but you just need to know how it is working, how the registers work, how one data is getting, and we store it somewhere, how we can add to data, how we can get the output out of it. All these are like a process that you will be learning, right? And in addressing modes, there'll be like simple programs of addition, subtraction, loops, how you can add delays before you give the output. For 8051, you have to learn the IO ports, timers, interrupts, and basic interfacing. And I still remember there was one traffic light program, that was like kind of difficult, but important that you need to learn that program. But it was a bit of difficult one to learn and keep it in your mind. So if you have watched this video till this point of time, you're already ahead of 80% of your batchmates. Like, they don't have an understanding of what they have to learn in the first level and then get deeper into each of them. So now since I've told you what are the base that you need to build, and you can feel free to share this video to your classmates as well. But what I'm trying to tell is, if you're watching this video till now, I've covered up almost like 80%, and for your embedded and IoT roles. Yeah. And next we are going to see this one topic. Is a bit a controversial one, because a lot of people try to skip it, because they think that this topic, the computer architecture and organization, so this is basically, since because it has the computer name, generally what people feel is this is supposed to be for computer science students, right? So many electrical students ignore thinking that this is for computer student. It's a big mistake. So basically, computer architecture and organization, it tells you how the instructions are getting executed, how memory hierarchy works, cache, RAM, storage, right? How pipelining works, how the parallelism and performance work. So these are all like, you get to understand how on high level computers work. Then only you'll be able to understand how you can develop these hardwares that enables these pipelines to work, right? When you're working in a, let's say semiconductor company, you're designing a chip for it. So you need to understand how the decision that you make on this chip affects the pipeline that is going to run. So this is a high level computer architecture that you will give you an understanding of how it works, right? This knowledge is important in VLSI. You will hear about pipelines, hazard, cache, etc. In embedded system, it's basically for optimizing the code for hardware, right? High performance computing and robotics and signal processing. So the key topics that you need to learn is basic computer CPU architecture, instruction cycles, pipelines, memory hierarchy, input output systems, and interrupts, how these works. Okay, understand the system point of view, and then you get into how you can develop it. Okay, I think I've covered the most toughest part, and one easy thing that you need to start right from your first year of college, but a lot of people won't do at the start and feel, oh god, wish I started earlier. That is the aptitude, right? Aptitude is the reality of campus placement. A lot of people avoid it initially, but then when they are in their fourth year or third year end, they think like, bro, I should have started it earlier, bro. Like, there are too many things to cover, but all of them are simple. So when you have simple things and too many things to cover, it's always should be compounded. You would have heard about the compounding effect, right? So when you are learning small things on a day-to-day basis, like aptitude, it's not like aptitude you don't need any prerequisites, right? It's just basic thing, but very important when it comes to code placement. You can expect a lot of questions, and especially in aptitude when it comes to code placements. So we get topics like in quantitative aptitude, verbal ability, logic reasoning, and puzzles. And I think this video is already, a long for me to get into topic wise stuffs. But I would say start building this habit of solving at least one or two easy questions as you start. I would say watch any YouTube channel in your mother tongue. But as I'm telling, when you learn it in your mother tongue, it's easy for you to keep in your brain and solve it as in a logic way. of doing it. Maybe I can come up with a detailed video of how you can learn and from where you can learn, but I just want to take you through it because it's important that you have to start small, like 15 to 20 minutes of your time. You can start from first year, but I would say at least if you are in second year, you should start it. Like one common book that we used was like R.S. Agarwal, okay? But it's not like you have to solve everything completely as well, but you need to have a basic understanding of these concepts. So yeah, so I've given you the complete roadmap for ECE. So I can give you a roadmap, but how you can also get familiar with it and learn these, right? So how to use the roadmap. So I have given you a 6-month game plan on how you can get into building strong basics irrespective of any year you're in. Okay, I think whatever I've given you, it just takes you close to 6 or 7 months. It depends on how much time you are able to give, right? If you're in first or second year, it would take you just 6 months for you to pick it up. But if you're already in like some third year and you have to like manage something else and also study, it may take you like close to 1 year for you to brush up all these fundamentals and get strong to it if you have not at all touched anything. See, in most of the cases, people who are sitting for placements, they don't have a proper idea of what they have to learn and things like that, and they, like, if you even have 10 months for you to prepare, I think you can follow this, right? And if you are in like second year, you have a lot of time, but use it in the right way, as I mentioned. How you can become from confused to confident, right? In the first 2 months, like first 60 days, give your time for C programming and digital electronics. Okay, why I've clubbed these two is because you don't need any prior fundamentals, because these are the fundamentals. So C programming, keep learning and practicing it in HackerRank. And digital electronics, I think digital electronics roughly takes around 1 week for you to learn the basics, right? So that's how I've clubbed. C programming is a bit tough for you to pick up, so club that and this. So you have 2 months to allocate for this, and then moving to the third and fourth month, start with electronic circuit analysis, that is the network theory. Okay, this is a bit vague concept, but you can pick it up, and I'm clubbing it with EDC. But before studying EDC, you should have at least covered the node analysis and mesh analysis of uh, the network theory. That is how, because sometimes you'll have clubbed questions when you're preparing for the gate exams, right? You'll have the EDC concepts running into the network theory, and questions like that will come up. I would say start with the network theory. I think you can like spend around 3 weeks for that, and then start practicing the circuit analysis questions. Once you are about that end of the RLC circuits, timing analysis, that part, uh, then you can start EDC. When you're studying, make neat notes of it, and also have a short notes, whatever you have studied, the formulas, quick tips, all that you have to revise then and there, right? That is for month 3 and 4. For month 5 and 6, I would say start with microcontroller and then focus on computer architecture, because in microcontrollers itself, when you're studying, you will have a lot of other units like ALU, how the CPU is working and stuffs. Then you can get ready for your computer architecture, and yeah, then assembly level programming. So this is a rough, how I would split the plan if I have to study again. So yeah, that is how you can get 10x times better than your friends, right? So I would say don't sit for one day study for 10 hours. Like if you're in your first or second year, spend at least like 2 hours daily, right? If you spend 2 hours daily from Monday to Saturday, you need not put like 10 hours on your Sunday, and it would feel easy. And this you can take as a personal advice, that what I have felt when you're doing the easy things again and again, if you are able to do tough things in small amount, that doesn't make you feel like your brain to feel like, oh my god, I have to study so much. But if you're able to do that small things again and again, you build a system. When you have a proper system, you get an habit of doing things and again, that push you in the right direction. The effort compounds and the result multiplies, and that is how you can get 10x better than average electronics or electrical student who is watching this video, right? So once you're done with these particular 6-month roadmap that you have done, then I would suggest you, like, you have a lot of companies coming in your college. Make a list of it, okay, before, like, make a list of it and find if all the lot of companies that are coming, if they are in VLSI, or embedded, robotics, or communication, right? And this is how I would approach for choosing which domain I want to get into. So for now, your goal is prepare a 6 month plan for yourself and start studying. Make a list of companies that are coming to your college, and then come watch my next video on one of these domains, right? I'll also let you choose what domain I have to pick and explain you how you can master in that specific domain. For example, VLSI, embedded system, robotics. So you just drop down in the comments. I'm anyway going to cover all three of them, but what I would suggest is I want to know what people want to hear from me, right? So if you can just let me know in the comments on what specific domain I have to address the next one, I'll do it for you guys. And if you have watched this video till now, I am also giving mentorship sessions non-stop, right? You can contact me for any specific mentorships on these again and again. I'll give the link to it in the description. Click on that, book a session with me. We can discuss on on one. We can discuss one-on-one, right? Now it's in YouTube, so a lot of people are watching. You'll not be able to discuss with me on how you can learn these concepts from where you can do. So yeah, if you have liked this, if you watched till now, please subscribe to my channel if you have not watched it. I know a lot of you are watching without subscribing it, and share it with your friends, and let's get stronger.